Hello, my name is Shri, and this presentation will cover image processing and extraction done manually using the notebooks in Toffy. If you have any questions or would just like to go over more detailed information, I highly suggest you refer to the README. Specifically in the image processing and extraction pipeline, we will be covering a manual extraction of bin files, generation of QC metrics, compute median pulse height, and stitching the image. This presentation will cover the four following notebooks. Notebook 3B, which is used to extract your bin files. Notebook 3C, which generates QC metrics. And then we generate MPH data with Notebook 3D. And then finally, we stitch images together with Notebook 3E. Let's start out with bin file extraction. Go ahead and duplicate Notebook 3B and open it up. The first thing you're going to do is get your run name and then get the panel path, which is in C users customer.ion documents panel files. And specifically, you get your panel file from the MIB tracker and then go ahead and download it and then save it into that directory. Next, you're going to load the panel. And then once it's loaded, it'll create any directories necessary that didn't exist before. And then you can extract the bin files. If there are FOVs that have already been extracted, then it will ignore them. Your FOVs will be saved in the extracted images folder. Now we'll generate QC metrics. Go ahead and open Notebook 3C. And we'll start out with setting the run name just like before. And then next it'll go ahead and create directories for that specific run in D data, and then in the customer.ion folder in C users. Next it'll gather all of the FOVs and then go through and create the QC metrics. And then you can also visualize your QC metrics. For example, if we look at KI67, on the left, we have an acceptable plot. As you can see, there's a slight decline, but it's mostly very steady. However, on the right, we have a very bad, almost exponential decline. This indicates that something went wrong here. In Notebook 3D, we'll be computing the median pulse height, also known as MPH. Go ahead and duplicate and open up the notebook. Just like in previous notebooks, we're going to start with getting the run name. Next, it's going to create the necessary directories to save the MPH data to and to load the files from. Then we're going to compute the MPH per FOV. And next, we can visualize the MPH plots. The following is a plot with a regression line, and MPH provides us a way to investigate the sensitivity of the detector. It's mainly used in Notebook 4B for normalization. Now we can go ahead and cover image stitching. Make sure you duplicate and open that notebook. Next, you will go ahead and set up the stitching run and then the paths. For the run name, this should be the exact name of the MIB run you wish to stitch the images for. And then the subdirectory is an optional parameter if there's a subfolder within each FOV. If this is not applicable, just leave it as none. And then finally, a channel list. This is an optional channel list specifying which channels to stitch for. If you leave it as none, it'll run on all extracted channels. Next, you're going to want to actually call the stitch images function. And then this will be saved in D extracted images run name under a subfolder called stitched images. Here is an example of a stitched image for CD20 for various FOVs. And then in summary, we've went over bin file extraction, creating QC metrics, computing the median pulse height, and then finally image stitching. And then up next, we will be talking about covering the extraction, generation of QC metrics, computing median pulse height, and then stitching all together in a live run.